Okay, today we are starting to learn about dilations. Let me zoom this in a little bit. You should have just read what a dilation is. Okay, who has the definition of dilation? Isaiah? Great. Okay, if you haven't already, circle dilation and underline the definition. So I have a question. Outside of math class in the real world, where do you see or hear the word dilation? Mara? The eye doctor, yes. Okay, I've only actually been to an eye doctor once in my life. Yeah, true story. My mom made me go right during my first year teaching before I went off my parents' insurance and onto my own insurance. Neither one of my parents had to wear glasses until my mom was in her 50s. She finally got reading glasses. So we were born with pretty good eyesight, thank goodness. Because my stepdad, he's pretty blind. His eyes are so bad, LASIK surgery couldn't help him. But, so, I remember this experience when I was right out of college, going to the eye doctor for the first time in my life, besides those little elementary eye doctors where you just do it with your elementary class, right? And they actually dilated my eyes. What happens to your pupils when your eyes are dilated? They get really big. And do your pupils turn into triangles? Astigmatism. Okay. Do your pupils turn into star-shaped? No. When your pupils enlarge, don't they just stay a circle? Yeah. So as the definition says, transformation that produces an image that is the same shape as the original figure, so it stays a circle, but is a different size. Now, I remember when I left the eye doctor, I still remember this. It was the eye doctor right by Coldstone on 54 South and State Street, Best Buy area. There's an eye doctor there. Okay, so I left and I was driving myself, which is probably a bad idea, because I was driving and I looked down at my cell phone when I'm at the red light, and I see, I have a text message, and I pick up my cell phone to see who texted me, and I couldn't see it. It was all blurry. I've never experienced blurry vision before. So I was doing the thing my stepdad does, trying to zoom in or zoom out until he can see it. And I was like, whoa, this is what everyone else feels like. Okay, or older people, you see your grandparents do that maybe when they're trying to focus in on something. So because my pupils had been enlarged, I had pulled away for me to see it. Okay, there was another definition in there we should have highlighted. Yes, center of dilation. So box up center of dilation and underline, if you haven't, the definition. Madison, can you read the definition nice and loud, please?
A fixed point in the plane about which all points are extended or...
Great. So with your pupils, the fixed point is the middle of your pupil, right? And it's enlarged and shrunk and large. But it doesn't always have to be in the middle. It can be on the side of the object. And there's one more. Looks like scale factor. Okay, scale factor. Torrance, will you read that, please?
The fact is the ratio of new image to the original.
Ratio of the new image to the original image. A ratio is a fraction. For instance, if we counted all the girls in here, I don't know, I'm just going to make it up. 12 girls, 15 boys. The ratio of girls to boys would be 12 over 15. Which can be simplified, but it's a fraction. So a scale factor, sometimes you see a scale factor as a number, an integer such as 2. Is 2 actually a fraction? Is 2 a fraction? 2 over 1, so it's still technically a ratio. Cool. First of all, I'm going to bring up, so I had the right document up at the beginning, just at the wrong time. I'm going to bring up a scenario. Go ahead and put your pencils down. And please listen to this scenario. Oh, right there. Oops. Up. Okay, please listen. Follow along the screen. Okay, Brunel has a new job at a copy center, helping people use the photocopy machines. Brunel thinks he knows everything about photocopies, and so he didn't complete his assignment to read the training manual. Mr. and Mrs. Donahue are making a scrapbook for Mr. Donahue's grandfather's 75th birthday, and they want to enlarge a sketch, that's what this is, a sketch of their grandfather, which was drawn when he was in college. They have purchased some very expensive scrapbook paper, and they would like this image to be centered on the page. Because they are unfamiliar with the process of enlarging an image, they have come to Brunel for help. Okay, we would like to make a copy of this image that is twice as big, centered in the middle of this very expensive scrapbook paper. Mrs. Donahue says, "Can you help us with that?" "Certainly," says Mr. Brunel, "glad to be of service." Brunel taped the original image in the middle of a white piece of paper, placed it on the glass of the photocopy machine, inserted the expensive scrapbook paper into the paper tray, and set the enlargement feature at 200%. In a moment, this image was produced. You think they're happy? Customers happy? "You've ruined our expensive paper," cried Mrs. Donahue. "Much of the image is off the paper instead of being centered. And this image is more than twice as big," Mrs. Donahue complained. "1/4 of Grandpa's picture is taking up as much space as the original." Okay, so I'm going to show you. Here's the original. Remember, he centered it on the page, and then what did he type on the copy machine? 200%, and this is what he got out of it. Okay, so I'm going to have you turn to a partner and answer. I have a few questions, just one at a time. Answer the following. Explain how the photocopy machine produced the partial copy of the original image. Because you can see he's missing the body and the ears and stuff. It's obviously not the whole image. So turn to your neighbor and talk about possible ways of why the photocopy machine only produced a partial image instead of the whole original image. Okay, turn to a neighbor and discuss ideas. Hopefully you've used a copy machine or seen someone use a copy machine or watched a movie where they use a copy machine. Take your knowledge and talk about why the photocopy machine only produced a partial image. Okay, this corner, I don't really see much conversation right here.
It was data.
Okay, so I'd like to hear some thoughts. And then before I ask the next question, some thoughts. Raise your hand if you've come up with some ideas as to why the photocopy machine has only produced a partial image. Zach? What do you mean it's not in the right spot? You're saying the original that he taped on was not in the right spot. Okay, well that leads us actually to the next question. Where should Brunel have placed the original image if he wanted the image to be centered on the paper? Okay, talk to your neighbor. Where should Brunel have placed the original image if he wanted the image to be centered on the paper? The outcome of that. Okay, so Alyssa? Top left, who agrees? Thumbs up? You're not sure, or thumbs down? Thumbs up, you're not sure, or thumbs down? Okay, interesting. I need a volunteer. Okay, Andy, thank you. Give me 1 minute. Okay, you ready? I appreciate Andy for volunteering. coming. Here's our friend Andy. Okay? I'm going to change this so I can put it wherever I want. Let's see, wrap text in front. So this is what Burnell did, right? He put Andy's picture right here. And then when it went 200%, what was also enlarged 200% besides the picture? All this white space, huh? So we don't just go like this. Well, actually, if we do, again, we only see the quarter part. Because all the white space was also enlarged. So let's decide if we had put it, Andy or the grandfather, up in the corner and we enlarged it, would it be centered? Yes. Because otherwise, all of this white space is also being doubled 200%. Okay? Go back to here. Thanks, Andy, for letting me use your picture. Next question. Mr. Donahue complained that the copy, remember this is the copy down here, was 4 times bigger than the original. What do you think? Did Burnell double the image or did he quadruple it? Okay, discuss with your neighbor. I'll read it one more time. Mr. Donahue complained that right here, this image was 4 times bigger than the original. What do you think? Did Burnell double the image or did he quadruple it? What evidence would you use to support your claim? Ladies? Whichever you decide, you need evidence for. So talk about reasons. Olivia, you need to talk with a neighbor. Spouty, maybe talk with Olivia, please. So just one person? Mr. Ayuke, is it just one person? Oh, it's 2. I don't remember the second one. Let me see. Oh, yes and yes. Okay, so who can answer if it's doubled or quadrupled and support your claim? Andy? Quadrupled? Okay, can you support your claim? Sure, please come up. Okay, who thinks it's quadrupled? Let's pay attention to his explanation. It's being recorded. Okay.
That whole it's right there.
You're saying the rectangle around the picture is exactly this rectangle. If we just split it over, would be this exact size.
And it's very like
Yeah, we'll just, okay.
it's very like a quarter of it.
Okay, so it's only displaying even like 25% of the actual picture around his face. Cool, okay. Who agrees with him that it's quadruple? Give him a thumbs up if you agree or a thumbs down if you disagree. The choices were doubled or quadrupled. So give me a thumbs up if you agree. I need everyone participating. Or a thumbs down if you disagree.
He said quadruple.
He said quadrupled. Thumbs up if you agree with his explanation and you now believe it's quadrupled. Or thumbs down that you disagree. All right. Okay, I have a question for you then. If I take, let's see, I'll take this yardstick. I really don't want to use a yardstick. I want to use this. It's a little easier to maintain. Okay, if I measure the nose piece of his glasses, I get a 1/2 inch. If I measure the new nose piece, I get a full inch. If I measure the width of his eyebrow, I get 1 inch. If I measure the new eyebrow, I get 2 inches. If I measure the opening in his mouth between teeth, oh, that's really small, a 1/4 inch. And then I get a 1/2 inch. So did it double or did it quadruple? Haha. Well, to be honest, I'm talking about two different things here. It one-dimensionally did lengths double or quadruple. Lengths. 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 Like the length of his, the width of his eyebrow. Okay, so one-dimensionally, in 1D, lengths doubled. But is the picture only one-dimensional?
Yes.
No. Isn't the picture two-dimensional? Two-dimensional, because we have a length and a width. Correct? Okay, we have a length and a width. So if I measure, say, the length of the whole picture, it's about 12 inches by 8 inches. And the new one only goes down to right here. How far down is that? Halfway, right? So the new one, in total, if we doubled that, would be, because remember, lengths are doubling. One-dimensionally, it's doubling. So this guy's doubling. If we took it off the page and could see the whole image, how long would it be? 24 inches. Okay, if we could see the whole width, all the way past his ear, how wide would the picture be? 16 inches. So what is the, let's calculate. Do you have calculators? You should pick them up when you come in. Please don't make me say this every day. Get calculators right now. I have a whole stash of calculators waiting for you. You need to calculate, please, the area of the original and the area of the new. Area, remember, is length times width. Area of the original. Let's start with that. Area of the original, length times width. I heard a girl has it. Annabelle, was that you? Yeah? 12 times 8, Annabelle? What do we get? 96. What's the unit in area? Inches. There you go. 96 inches squared. Everyone else, please find the area of the new. That's in inches. That's weird eye. 384. Does everyone agree with that? 384 inches squared, because we're in 2 dimensions. Okay. Well, did it double? 96 times 2. What is 96 times 2? 192. Is that the same as 384? No. So please figure out, how did the area change? We just talked about what it hasn't doubled, but instead, please figure out what has happened to the area. Once you know, don't say it out loud, stand up. Once you know what has happened to the area, please stand up. Thank you for standing. Once you know what has happened to the area, please stand up. When you know what has happened to the area, we just talked about it, it hasn't doubled. The area has not doubled. When you know what has happened to the area, please stand up. Okay, this corner, I need more participation. How does 96 change to 384? Please figure it out. Thank you for standing and being patient. Well, how does 96 change to 384? How does 96 change to 384? Times it by what? Not by 16, that would be super huge. There is a number. Well, if you try it, 96 times 8, try it. 96 times 8, does that give you 384? Oh, too big, right? Okay, everyone have a seat. Jamie, what'd you get? 96 times what gives you 384?
4.
Times 4. What about the rest of you? Do you agree?
Yes.
Yes. So 96 times 4 equals 384. So, for the picture itself, which is in 2 dimensions, the picture did not double, but what did it do? Quadrupled, so Andy was correct. Good job, Andy. Everyone give him a round of applause. Everyone give him a round of applause, please. That's a weak round of applause. Thank you. Okay. So, by the way, what we've done here is called dilation. But like we've mentioned, we really needed to put the, the picture in the top right-hand corner so we're not also enlarging white space, right? We just want the picture so we don't waste those kind people's really expensive scrapbook paper. Cool. All right. Now you have a little more background on actually what a dilation is. Head back to your notes and we're going to work out some on a coordinate plane, on a graph. Head back to the notes, please. I feel like it needs to be zoomed in more. Example 1. There is a triangle, A prime, B prime, C prime. This is actually, let's put the word new. My line is too thick. Skinny line. New image. It is a dilation of triangle ABC. That's the pre-image. Pre is your starting image. With a scale factor of 3. With a scale factor of 3. So, the primes, guys, represents the new image. So the original image will generally be the ABC with no primes. Okay, point O is the center of dilation. So the origin here is the center of dilation. As we just talked about, if we're going to dilate something, what's going to happen to the lengths? If our scale factor this time is 3, what's going to happen to the lengths? In one-dimensional, looking just at the lengths only, what's going to happen if the scale factor is 3? Everything's going to be tripled. So let me show you a connection. Well, lengths are doubled. How does doubling change into a 4? If our scale factor originally was a 2, with our picture of the grandpa, how does 2 change into a 4? Times by 2, or could you say that's also 2 squared? Yeah, 2 squared equals 4. Yeah, so that's how we figure out what's happening to the area. You take the scale factor and square it. If this was a volume, if we were looking at a 3-dimensional item, it'd be the scale factor cubed for the volume. So the volume increases, cubes as much. So if our scale factor was 2, it would now get 8 times bigger. Okay, so on here, if our scale factor is 3, keep in mind that that actually means all the lengths are going to be tripled, but the area, I'm zoomed in too far, so give me a really thick marker. The area is not going to be tripled. Scale factor squared. 3 squared. What is 3 squared? 9. So we'd actually get 9 times more area. 9 times larger. More area. If this was volume, it would be 3 cubed, which would be 27 times more volume. Okay, so O is our center of dilation. Remember this little triangle ABC. Madison, can you please put it away? Triangle ABC is the original, which is this little guy. And it tells you the points. Let's put the points on. A is 1, 0. Let's put that point by A. 1, 0. Label, please. Point B is 1, 2. Oops. I missed the 1. And point C is 5, 2. A prime, it also gives you, is 3, 0. B prime is 3, 6. C prime is 15, 6. Okay, so because of the scale factor, we'll know how far it will be away from the center of dilation, which right now is 0, 0. For the first point in point A, how far is point A away from the origin? To the left. How many units to the left along the x-axis? 1, right? And it even shows you a 1 right here. Okay, how far away from the center of dilation is A prime? 3. So is it true that it tripled? Because the scale factor is 3. Let's check the heights. Let's look at B for the heights. How far vertically up is point B? From 2. And how far vertically up is B prime? 6. Is it true that 2 times 3 is 6? Yeah, you can check through the whole thing and it all works, as well as these diagonals are all being tripled. Diagonally, their distance away from the origin is being tripled. So, the ratio of the lengths from the center of dilation to the coordinate is always equal to the scale factor. Okay? So, you said like this one, the new one was 3 away from the origin, and point A was 1 away, which is equal to the scale factor, because it was tripled. Okay, next example. Oops, too big. We're going to actually find, I believe, the points. Yep. Example 2. Dilate the triangle with vertices A, B, and C that are given. Scale factor 2, centered at 0, 0. Underline, please, scale factor 2. That's very important. Also, center of dilation is very important. So here is O. This is example 2. Okay, the first thing you need to do is plot all 3 points and then connect them. It should form a triangle. So would you do that, please? Plot all 3 points and label. Label A and put in their values 0, 0. B, 4, and their values 4, 0. And C, 4, 1, 2, 3. And connect them as a triangle. We're going to use the center of dilation and the scale factor to dilate this triangle so it gets larger. If the scale factor is larger than 1, it's going to increase. It's going to get bigger. So how would we shrink an object? Okay, division. Kind of like what type of number has a division bar in the number? Yeah, say it louder. A fraction. So if our scale factor is a fraction, less than 1, then it will be shrinking. Okay, so here we have a scale factor of 2, which is greater than 1, so it should be enlarging. Okay, so first of all, on point A, how far away from the center of dilation, O, is point A? 0. Okay, so really, A prime will be 0 times 3 and 0 times 3, which is still 0. Okay, point B, we're going to multiply by 3. 4 times 3 and 0 times 3. Well, what's 4 times 3? 12, and below 0 times 3? 0. Okay, we can plot that one. Let's see, 12 is way over... Oh, why am I timesing by 3? Excuse me. Was that our last one? What should we really be timesing by? 2. Sorry about that. 2, 0. I realized, oh, wait, we're off the page. So that would leave us with 8, 0. 4, 5, 6, 7, 8, 0. Mark that and label it B prime. It is now 8, 0. A prime is on the same position as A. And then we have one more to do. timesing by 2, sorry, I got the wrong number in there, timesing by 2, Michael, 4 and 3 times by 2. 4 and 3, point C. C is 4 comma 3, so we multiply both those numbers by the scale factor. So what's 4 times 2? Okay, and 3 times 2, good. So plot that one, 8, and then up 6, 1, 2, 3, 4, 5, 6, and that would be C prime. Make sure you label it and put the coordinates, and then connect them. And what has actually happened here with the area, if the scale factor is 2, then we take the scale factor and square it. So the area has become, what's 2 squared? 4. So the area has become 4 times larger. Okay, let's try example 3. The first thing you need to do is plot the points. And then underline the scale factor. Plot the points. 1, 1. And that was A. B is 4, 1. Make sure you're using the x coordinate. The first number is your left and right movement. Second number is your y coordinate, which is your up and down movement. And then 4, 4. 1, 2, 3, 4. There it is. Okay, Olivia, what's the scale factor this time? No, scale factor. You gave me point A. 3. Okay, and center of dilation is at, again, 0, 0. Okay, that's not what I want. This is what I want. Okay, so put in your center of dilation, 0, 0. And it's O, because it's at the origin. So we take A, B, and C, and we multiply by our scale factor. Okay, Vanessa, A is 1, 1. So can you tell me what A prime is when we multiply by the scale factor? What? 3, 3, yeah? 3, 3. B prime when we multiply by the scale factor, Justice, what would B prime be? Multiplied by 3. Our scale factor this time is 3. Yep. 3. Okay, great. And C prime I'll put down here because it's over the graph. C prime multiplied by the scale factor. Myra, 4, 4. Multiply both those by 3. What do we get? 4 times 3 is 12. So we'd have 12, 12. Okay, let's plot those and label them A prime, B prime, C prime. So 3, 1, 2, 3, 1, 2, 3. That's A prime. 12, 3. Here's 14, so 12 would be right there. And C prime is 12, 12. Okay, connect them. Okay, since the scale factor is 3 and you square the scale factor, please turn to your neighbor and tell them what happens to the area when the scale factor is 3. Not so. Nope. Remember, the scale factor is squared. Please turn to your neighbor and tell them what happens to the area when the scale factor is squared. Do you know, Ariana?
Yeah.
What happens to the area, please, Ariana? Oh, no, distances lengthwise doubles, but area is two-dimensional. Scale, it's not, it doesn't triple, though. Jaren? 9 times, because you take the scale factor, which is 3, and you square it. 3 squared is 9. It's 9 times larger. Okay, here's yeah, dilations can be performed in other shapes besides triangles. We showed it with that dude's picture. Your eye is not a triangle, that's definitely a circle. These shapes can be in any of the 4 quadrants or even more than one quadrant. The dilation can also shrink. Remember, we just barely talked about this. What would the scale factor be in order for the dilation object to shrink? Lucas, say it again, please. Fraction. So our last example is example 4. This time, look at our scale factor. It is a, example 4, it is a F-R-A-C-T, fraction. So that means our new image is going to shrink. Okay, this is the last one we're going to do before we do an activity. All right, plot A, B, and C, and D. Oh, 4 points. Is this a triangle anymore? No, it is a, well, it could be a parallelogram. It's at least a quadrilateral, correct? We don't know yet if all the sides are parallel, if we have 2 pairs of parallel sides. But it's at least a quadrilateral. So please plot all 4. Negative 4, 4. 1, 2, 3, 1, 2, 3, 4. That would be A. 6, 6. 1, 2, 3, 4, 5, 6. Oh, 6, 6 is up here. And you should be labeling. C is 6, negative 2. And D is negative 4, negative 4. And then connect them. So in order to find the dilated points, again, the center is at 0, 0, which is nice. We multiply by the scale factor. But timesing by a fraction is a little tricky. What's equivalent to timesing by 1/2? You can tell me what's equivalent to timesing by 1/2. Ooh, halfway correct. What's equivalent to timesing by 1/2? Amina, do you know what's equivalent to timesing by 1/2? Dividing by, not 1/2, dividing by 2. Dividing by 2. So I'm going to let you figure out A prime, B prime, C prime, and D prime. The shortcut is just divide all these by 2. Divide all of them by 2. And then plot them, and it should shrink. Divide all of those vertices by 2, the x and y coordinates. And then once you've done that, plot them, please. Okay, did it shrink? Yeah. Now, let's talk about the area really quick. What has happened to the area? Remember, to see what's happened to the area, you take the scale factor and you square it. So 1/2 squared. What's 1/2 squared? Mara? 0.4? Oh, 1/4, yes. 1/4. So what's happened to the area? Ooh. It's not 1/4 smaller. It's 1/4 the size, which actually means it's 75% smaller. Ah, that's tricky, huh? Because 1/4 is the equivalent to 0.25. So the new image is 25% of the original image. So it's actually 75% smaller. That's a little tricky in area. Okay, we're just going to make sure that side lengths are proportional. Okay, A prime, D prime, the vertical ones are the easiest ones to look at. A prime, D prime, how long is this side? 4, yep. Over A to D, how long is that side? How many boxes? So how many boxes total? From A to D. 8. Is that our scale factor? That's 4/8 our scale factor? Yeah, and we could do it on all 4 and we would see that, yes, the scale factor, the ratios hold true. Cool. We can do an activity now where, we're going to skip those for today. Have you seen this symbol before? Google Chrome. Just like our picture of Mrs. Donahue's and Mr. Donahue's grandfather, they tried to dilate that, and unfortunately Brunel failed miserably. We're going to hopefully not fail miserably, and we are going to dilate the Chrome by hand. So, I need a volunteer to pass the worksheet out. That's the one I'm showing, and then, volunteer? Diana, thank you. And then I'm going to distribute a couple piles of rubber bands. Each person needs to find 2 rubber bands pretty equal in size. However, don't use these itty-bitty ones. They need to be like medium size. Also, don't use these ginormous ones. You need to find 2 rubber bands that are equal in size. So you guys can come look through there, find 2 that are equal in size. And you guys can come look at Laurel's desk. I'll dump some out. Try to not keep them on the floor. Stand up. Come find 2 rubber bands equal in size that are like medium length. Not enormous, not teeny. Okay, hustle guys. Find 2 medium-sized elastics. They should be the same type, same thickness too. Don't do the really small ones. Don't do the huge ones. Medium-sized. 2 that are pretty close. What? Oh. Are you sure? Oh, here we go. What? Yeah, hurry.
Where is it?
He just had it. It's in the back.